Jared.
Hello.
So.
Can you hear me, Jared?
Have you been presented with a problem like this before?
Probably.
The numbers look similar.
In pre-calculus. Oh no, not with the integral. No.
Oh, you can do this one.
Oh. Can
Yeah, you can use
you're off by
substitution.
just a half.
silly friend.
Right? So then we could do 1/2 integral of 1 over u du. Okay, now that worked out nicely because our denominator was like it's planned out, right? What if that was x plus 7?
That would not be fun.
We could buy.
Uh,
Would be fun.
Well, we would not have a nice multiple for the du. We would not be able to do u du substitution. Okay? So, instead, we need a way to break up these fractions. Here's another way, then. So, fractions can be written as a sum of fractions, right? So if we have a rational expression, right? Then it can be written as the sum of fractions, where this is like a over x minus 1 plus b over x minus 17 plus c blah 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 blah, right? Or if we have like a quadratic factor in the denominator. Oh, these are too many letters. Right? Then we would have to put a linear numerator. I remember doing that. Okay. Basically, we're going to do partial fraction decomposition, and we're going to remember back 2 years of pre-calculus how to break these fractions apart. Okay? So if you remember, we factored our denominator so that we can break it up into that many fractions. Okay? If we have a linear denominator, then we're going to put a constant in the numerator. If we have a quadratic denominator, we're going to put a linear in the numerator. Okay? So, now remember, all of these strategies are if u du substitution can't work, right? U du substitution is nice, but sometimes it can't always be used. Like here, if we let u be the denominator, du would be 2x plus 3. Not really working out for us, are we? Are we really that close? Okay. So let's just take a break here and do some partial fraction decomposition. So first rule, we got to factor the denominator. X
Minus
Plus 5.
Plus 5. Plus 5.
Oh, sorry. So this is going to be a constant over x plus 5 plus some constant over x minus 2. We gotta figure out what those numbers are, okay? So, to help us figure out what A and B are, let's multiply by our common denominator. So that we are left with 8x plus 82 equals A times x minus 2 plus B times x plus 5. Now we need to figure out A and B. We don't have to. We can pick numbers to help us out. Can I plug in x equals 2?
Yeah.
Why did I pick x equals 2?
Make A 0 area.
Make that go away. So what is 8 times 2 plus 82?
98.
Equals A times 0 plus B times 7.
7.
What?
98 seconds.
Or 14.
I didn't say. I feel like it works out nicer than just
I don't
98
know.
sevenths.
You
Okay, so there's B. Now what can we do?
Again, -5.
Plug in -5. So we have -40 plus 82
42.
equals A times -7 plus B times 0. So what is A?
86.
What?
86.
So what we have is -6 over x plus 5 plus 14 over x minus 2. Let's go back to our integral. This is now what we're integrating.
Hooray. We can just reuse them.
Do we need use?
Simple.
What's the antiderivative of this?
This is what I used to use it.
Did you?
Technically.
Plus 14 times?
Actually, yes.
Okay. Now, there will be times where, like in a multiple choice question, they might condense this logarithm to be the natural log of x minus 2 to the 14th divided by x plus 5 to the 6th. How'd I get that?
Some like
Rules. A few blocks. Put the 2 to the top and then divide it.
Okay. Alright, see, that wasn't too painful, right?
I think it was painful in pre-calc.
Things in pre-calc seem so easy now, right?
I think it was painful in pre-calc mostly because it was long.
But now we've done stuff
We
like
just
this.
came up with trigonometric. Brave.
Okay, so another 10. Ouch.
Okay. So, will any sort of substitution work here?
Probably not. Chances are slim.
I sure hope not.
Shape the A-ball.
So,
Magic cue ball.
let's decompose our fraction. So 6x plus 7 over x plus 2 squared. How many factors do we have in our denominator? 2. So we're going to split this up into 2 fractions. One with a denominator of x plus 2.
Yeah, but x plus 2 squared.
Ah, why?
Because that's how I learned it in pre-calc.
You had a great pre-calculus teacher.
Who was that? That was her.
Wait, maybe you were
To be fair, I learned that from Hazelwood.
Yeah.
Okay, so if, let's just think about this. If we had this only as x plus 2, because those are our two different factors,
Oh, when it's actually together, it's going.
we
It'd
can
just
just
be
add
like
them together.
2x.
That's the common denominator, okay? We want a common denominator of x plus 2 squared. Okay, so what goes up here? And here?
Like bx plus c.
If it were a true quadratic factor, but since it's a repeated linear, we still treat it as a linear
Okay.
factor.
So you don't
Okay.
really have to remember the plus.
Nothing. You said so you don't have to worry about the plus c's.
Did I forget my plus C?
No, you had
No.
it. It was just
Okay.
in this one.
I
you don't.
did it. So we're gonna multiply by our common denominator. So we have 6x plus 7 equals a times x plus 2 plus b.
That needs to be -2.
So we get negative 12 plus 7
Equals B.
equals 0 plus b. Don't we need an a? How will we get our a?
I suggest you plug in whatever you want.
We could do 0. 0 is
I think it's
yeah, 0.
Doesn't matter what we plug in right now.
no.
If we plug a number in for x, we have b, so a would be our only missing value. I'm gonna choose b.
0.
Okay, so continuing with our integration, we have the integral of 6 over x plus 2 minus 5 over x plus 2 squared. Why are you saying, oh no? This one.
6 natural log over x.
Good.
This is negative 5 x plus 2 to the
Negative first.
negative first divided by negative 1 plus b. I started writing something else and I changed it to that.
I wasn't sure if Mark would spazzed out and I was looking down.
No, I stepped out. Thank you, Tom.
Okay. You're gonna write.
That's
I
a
started to write
five-under
X.
relativity.
Okay, that's what I thought.
Yeah.
I'm really confused.
Does it look like a 5?
Yes.
You're going relativity.
It looks like it's like those kids in cartoons where the head is too big for the body.
Yeah.
I'm leaving it. I don't care what you say.
Good.
We have another problem.
Did we just?
Oh,
go there
sorry.
and put up now?
Sorry. I was in the habit of like the next slide has the next one.
For a second.
Uh-oh.
Uh-oh, what?
We got a quadratics, and now we got it out to EX plus C. Hooray!
So, 1 over x times x squared plus 2 is going to be the sum of two fractions. One has a denominator x, the other x squared plus 2. What goes above x?
A.
Constant. And above our quadratic factor,
EX
Plus C. Kind of important. It's chocolates.
why is what?
Why is that go?
Halloween safe night is.
Can't wait to have
So we have 1 equals a times x squared plus 2 plus bx plus c, the quantity, times x.
I suppose we plug in square root of 2 times I.
Okay, that's not a real number.
I suppose we, literally, I suppose we plug in zero.
So that's not gonna work out so well.
I like zero.
Then yeah, 0 works too.
Okay.
Zero works too.
So we get 1 equals a times 2. Now what? Let's do this.
Divide out the x.
We can't divide by it. Why did I do that? Okay. Well, let's think about this. I have 2 equations that are equal. So whatever is over here needs to be over here. So how many x squareds do we have? Over here.
Oh,
Well, when you
equals
multiply
b.
it,
Hold on. Please answer my question. How many x squared do we have? We have 0 x squared. So ax squared plus bx squared should equal 0. A plus b better equal 0. What is our x over here? 0. So c better equal 0 because there is no x. What is our constant?
1.
1. Oh, we already knew that. 1 equals 2a. Yes, you could.
Can you do that for all of them?
Yes, but you could get a system of equations sometimes. And so if you have linear factors, plugging in zeros is much quicker. Okay. And so what's b? So we have the integral. So a was 1/2 over x plus negative 1/2 over x squared plus 2. Okay, is that seriously what that should look like though? I'm going to do 1/2 integral 1 over x minus 1 over x squared plus 2 dx. Oh, but it's not x, is it? Because it was b, right? It was bx plus c.
Brilliant.
Whew.
Oh, yeah, I was gonna.
Okay.
Or even possible partial fraction.
Okay. So, how are we going to integrate this one?
Easily. No.
Say it louder.
Nice.
Yes.
Okay.
Okay. How are we going to integrate this one?
Yeah, you can use
have
the
a
one.
You're going to have to do u du. U is x squared plus 2. Du is 2x. dx. So we have 1/2 the integral of 1 over u du. Right?
Yeah.
So we have minus 1/4 the natural log. Why did I put it in parentheses instead of absolute value?
Because it can't be negative.
X squared plus 2 is always positive, so it doesn't matter.
But it is generally still correct either way.
Yes.
Yeah, this is fun.
I'm glad you were having fun. Fun with fractions.
What?
Anybody want to
Sheldon from that recently.
And I just got in the way.
I understand the reference, I just don't care for the show.
Fair
I
enough.
used to watch the show a lot.
Sheldon does a show called Fun Flags. I love when my jokes have no meaning to you. Let's get started.
Never mind.
But